Welcome to the Journey Chez Chem. Well, you know how excited I am because today we're going to do lab. Well, please do the warm-up questions as quickly as possible, and we'll see you in a moment. Number 1 asks what occurs along the lines of the phase diagram. Well, equilibrium. It's a balancing point because right along the line is freezing and melting, or condensing and boiling, or sublimation and deposition. So it depends where you are, but all along the lines we have equilibrium. Number 2 asks why a steam burn causes so much more damage than a boiling water when they're both at the same temperature. Well, remember that boiling water does not have the heat of vaporization. When you change that compound of water from a liquid to vapor, it requires the heat of vaporization. It requires energy to overcome those forces that make it a liquid to change it to a vapor or a gas. So it has the heat of vaporization. So steam has a lot more energy. But we're not going to burn ourselves with steam or boiling water. That's just too painful. But we want to know what the difference is between them. So steam has a lot more energy. Okay, well, I'll see you in the lab. Here we are in the lab again. I can't tell you just how excited I get. Well, today we're going to determine the heat of fusion and the heat of vaporization. And first of all, I'm following my procedure. I have 2 styrofoam cups, and I will get the mass, 7.95 grams. 7.95 grams. Now, I'm going to write this down, the mass of my calorimeter, 7.95 grams, and I'm going to add some water. I add the water, and I mass it again, and it's 139.87 grams of my calorimeter and water. 139.8. Oh, it's a little bit in between there, isn't it? Because I'm estimating the hundredths place, so it was fluctuating there, but it seems to be at 86 grams. 139.86 grams. Now, I will see you at the lab station. It's important to look at the thermometer and see the graduations. And I can see that this has measurements to the 10th place. There are 10 lines between the 20 and the 30. And therefore, each little line is 1/10 of a degree. And therefore, I'm going to be estimating what that is. I want the initial temperature of my water. And I have to give it a moment to get to its temperature. And I see that the temperature is 23.0. 23.0 is my initial temperature of the water. 23.0. Now I'm going to add a small amount of this ice, and I'm going to assume that it's 0 degrees. And then I will rush to the scale and get a mass of the ice that I have put in here. And then I'll record the lowest temperature to which it goes. So I'm going to add some ice, and I'm going to go and mass this. I'll see you at the scale. The mass is 206.00. 206.00. It's fluctuating in between, but it seems to be stabilizing at the 0.00. 206.00. And now I must get the final temperature after all the ice has melted. And I have to wait for all the ice to melt. And I'll see you at the lab station for the next part. Now all the ice has melted and I can get my final temperature of the water. And I see the final temperature of the water to be 1.9 degrees. 1.9 degrees. 1.9 degrees is my final temperature. And that's the data that I needed for this portion of the lab. 1.9 degrees was my final temperature of the system. And the rest of that you can do to determine your further investigations and complete the data table. You have all the data that you need to determine those numbers. Now, I'm going to do part B. In part B, we have to use the Bunsen burner. All right, I love the Bunsen burner. Makes me happy. Now, I have to determine the mass of my calorimeter. Well, we have the mass of the calorimeter from the last section. And we want to fill it again with water. And therefore, I am going to see you at the scale. I just can't tell you how excited I am to be at the scale. I just want to jump up and down. I'm so excited. Well, here I have some water in my calorimeter. I'm going to get its mass. 141.08 grams. Oh, it seems to be fluctuating. Let's move it to the middle of the pan and see. 141.08 grams is the mass of my calorimeter and water. Now I'll see you at the lab station. Oh, here I am at the lab station. Well, I'm going to set my water with a thermometer aside while I light the Bunsen burner, because you know I love lighting that Bunsen burner. Well, here we have a steam generator. This, I will heat it up and I will be able to see the water that's in here in this portion of it, and then steam will come out of the hose. And that's what I will use in order to determine the heat of vaporization. And I'm going to turn this a little bit so that it's facing and you can see it clearly. Now I have to be careful because this is a rubber tube and I don't want to get it into the flame. We do have to be cautious about some of these things. I'm turning on the gas and I'm lighting the Bunsen burner. Whoa, Bunsen burner excitement. Okay, now I'm going to heat up the water. And it may take a few minutes for the water to begin to boil. And while it's doing that, I am going to get the initial temperature of the water. And when I look here, I can see that it's about 23.8 degrees. 23.8 degrees Celsius. That's my initial temperature. And I'm going to record that. Initial temperature of the water is 23.8 degrees Celsius. And then I just have to wait for the steam to be generated. And it shouldn't be too long because we have quite the heat coming off of that Bunsen burner. Now, remember that I'm getting the data that you need in order to be able to answer the conclusion questions and complete the data table. Then it's your responsibility to complete this. And remember that in the further investigations, the purpose of some of those questions is to focus on what we were learning in the lab. And therefore, it might be about the heat of fusion. You just never know. You have to read the questions and see how it goes. Well, we need to wait here and be patient. And know that patience is just something I'm always working on in the lab. Patience, patience, patience. Hopefully it will begin to boil any minute. I can see in the side there that there are no bubbles yet. So I'll wait for you and I'll come back in a moment. Oh, we got steam. So the initial temperature, it was 23.8 and I wanted to go up to 43.8. So I have to watch it while I'm putting the steam in the water. And look at that steam go. We're going to put this steam into the water and wait for the temperature to come up to 43.8. Sounds like I'm making an espresso. Or maybe a latte. Or maybe a cappuccino. I don't know. Maybe just some hot chocolate. That would be good too. Just let it go, let it go. And we can see the temperature is rising. Oh, it's above 30 and we only need 43.8. Then I'll quickly mass it to find out the mass of my steam. Now, this is a source of error because reading this thermometer, I'm already at 45. So I'm going to stop with the steam. Woo! I'm going to turn off my Bunsen burner and I'm going to rush over to the scale. And I'll see you there. Now, it's fluctuating. 147 point, well, the steam's rising. So we'll go with the first one, 147.33 grams. 147.33 grams is the mass of my water, calorimeter, and steam. Well, that was some fun. Now you have all the data points you need to calculate the kilojoules per mole for the heat of fusion and the heat of vaporization. That was some fun, and thanks for being here with me, and I'll see you tomorrow.